And welcome back, students, to another lesson on recursion. Today we're going to delve into recursive methods that return a value, specifically by looking at a general form for such methods. So as we get started here today, the recursive methods that we have seen thus far are all void methods. But as you may have already guessed, recursion is not limited just to these methods. A recursive method can return a value of any type. The technique for designing recursive methods that return value, therefore, is basically the same as what you've learned for void methods. So an outline for a successive recursive method definition that returns a value is as follows. You have one or more cases in which the value return is computed in terms of calls to the same method, that is, using recursive calls. And as is the case with void methods, the arguments for the recursive calls should be intuitively be smaller. Then you also have one or more cases in which the value returned is computed without the use of any recursive calls. These are cases without any recursive calls that are called base cases or stopping cases, just as they were called when we had our void methods. Alright, and the best way to kind of illustrate this today is going to just look straight at an example, and that is going to be another powers method. So if you recall back in programming 1, we introduced the static method pow of the math class that computes powers. So for example, math.pow of 2.0, 3.0 sets the variable result to 8.0. Then you have double result equals math.pow of 2.0, 3.0. The method pow takes two arguments of type double and returns a value of type double. Now, recursion demo 2 also contains a method recursive definition for a static method that is very similar to that of pow, but that works with the type int rather than the type double. This new method is called power. So for example, the following would set the value of result 2 equal to 8. Int result equals power 2, 3. Outside the defining class, this would be written as int result 2 equals recursion demo 2 dot power 2, 3. So our main reason for defining the method power is to have a simple example of a recursive method, but there are obviously situations in which the method power would be preferable to the method pow. The method power returns a value type double, which is only an approximate quantity. The method power returns a value type int, which is an exact quantity. Now, in some situations, you might need the additional accuracy provided by the method power. All right, and before we move on, let's just take a quick look at that recursion demo. And so you can see in here, we have our main method here, which simply just has a for loop here. And all that does, it just says for n is starting at 0, going up to 4 here. So it's going for 3 iterations. 3 to the power of n is power 3, n. So then we just call this method right here power. And it says when n is less than 0, you say equal argument to power, so negative 0, because that's saying like 3 to the negative 1. Obviously, yes, you can have negative exponents, but for our purposes, we're going to ignore this. If n is greater than 0, we're going to go ahead and do our computation. And so we're going to say that we're going to return power of x, n minus 1 times x. Right? And of course, right here is your recursive call. Then you have an else, which is just simply when your n is equal to 0, you can just return 1 because anything to the power of 0 is 1. So if I run this program, I get 3 to the power of 0 is 1, 3 to the power of 1 is 3, 3 to the power of 2 is 9, and 3 to the power of 3 is 27. Now, you'll notice that if I wanted, for example, just to compute like this example right here, I just want 3 to the power of 3, then I wouldn't have to put this in a loop. I could just simply just run this system.out.println command to generate that one. But in this case, this is to kind of show the step-through process of how this would work. All right, so kind of a quick and easy one here. Again, just real simplistic to help demonstrate how that power class works. Or method, I should say. So the definition of the method power is based on the following formula. X to the n is equal to x to the n minus 1 times x, because, well, n minus 1 would be 1 less. So if x to the n is, let's say, 2 to the 3, x to the n minus 1 would be 2 to the 2 times 1 more x. That's the same thing as adding in that 1 more power. So translating this formula into Java says that the value returned by power of x, n should be the same as the value of the expression power x, n minus 1 times x. The definition of the method power given in recursion demo 2 does return this value for power x, n, provided that n is greater than 0. So let's see what happens when the method power is called with some sample values. First, consider the simple expression power 2, comma 0. When the method is called, a value of x is set to 2 and the value of n is set to 0. The code of the body of the method definition is then executed. Because the value of n is a legal value, the if-else statement is executed. Because this value of n is not greater than 0, the return statement after the else is used, so the method call returns 1. Thus, the following would set the value of result 3 equal to 1. Int result 3 equals power 2, comma 0. Now let's look at an example that involves a recursive call. Consider the expression power 2, comma 1. When the method is called, the value of x is set to 2 and the value of n is set to equal to 1. And the code of the body of the method definition is executed. Now, because this value of n is greater than 0, the following return statement is used to define the value returned. Return power, parentheses, x, comma, n minus 1, parentheses, times x. Which in this case is equivalent to return power 2, comma 0 times 2. At this point, the computation of power 2, comma 1 is suspended. A copy of the suspended computation is placed on the stack, and the computer then starts a new method call to compute the value of power 2, comma 0. And as we have already seen, the value of that power is 1. So after determining the value of power 2, comma 0, the computer replaces the expression 2, comma 0 with its value of 1 and resumes the suspended animation or computation. The resumed computation determines the final value for power 2, comma 1 from the above return statement as power 2, comma 0 times 2 is 1 times 2, which is 2. So the final value returned for power 2, comma 1 is 2. So the following would reset the value of result 4 equal to 2. Int result 4 equals power 2, comma 1. Now, large numbers for the second argument will produce longer chains of recursive calls. Obviously, we looked at something really small with just being to the power of 1. So, for example, consider the statement system.println power 2, comma 3. The value of power 2, comma 3 is calculated as follows. You'll have power 2, comma 3 is power 2, comma 2 times 2. Power 2, comma 2 is power 2, or 1 times 2. Power 2, comma 1 is power 2, 0 times 2. And power 2, comma 0 is 1, which, of course, is their stopping case. Now, when the computer reaches the stopping case, there are 3 suspended computations above it. So, after calculating the value for the stopping case, it then resumes the most recently suspended computations to determine the value of 2, comma 1. After that, it completes each of the other suspended computations, using each value computed as a value to plug into another suspended computation until it reaches and completes the computation for the original call power 2, comma 3. So, if you want to kind of have a little bit more understanding how this might work, here's a quick illustration. So we're starting right here. We have our power of 2, comma 3. So then what it does is it breaks it down into a power 2, comma 2 times 2, breaks that bubble down into power 2, comma 1 times 2, and breaks that bubble down into 2 power 0 times 2, which of course is 1. Then to compute the final value, it's going to come over here and work in reverse. Well, I can take 1, I can plug that back into the original expression, so 1 times 2, so that gives me 2. Take that, plug that back into that suspended expression, so I get 2 times 2, which of course is 4. Plug that back into the suspended expression, so I get 4 times 2, which of course is 8. And then plug that back in here, which of course notice there is nothing for it to multiply, so we just get a result. So power 2, comma 3 is 8. And that's going to wrap it up for today, folks. So until next time.